Section 7.2, example 6, finding the second derivative. So calculate the second derivative for the plane curve defined by the parametric equations below. Okay, so we have all of this right here. And I feel like it should be as simple as just, oh, take the second derivative and then divide them by both. But it's just the tiniest bit different. So I'll give you the formula here. So we have d2y over dx2. So this is a second derivative. This is the derivative with respect to t of dy dx. And we're dividing that by dx2t. Yep. Simple as that. All right, so things we have to find. Dy dx, dx dt. Well, we're going to find dx dt when we find dy dx, and then we're going to take that derivative. All right, let's start with grabbing each of the equations and taking the derivative. So we have x is equal to t squared minus 3. Dx dt is equal to 2t. Easy. And we have y is equal to 2t minus 1. Dy dt is equal to 2. And from here, we could find dy dx. So dy dx is equal to dy dt over dx dt. So that's 1 over t. All right, so we have that. We have this part so far. We actually have this part too. So x dt is this one right here. Super cool. Oh, we have to take the derivative with respect to t of dx dt. So let's do that. All right, so now the derivative of d with respect to t of dy dx, that's going to be, think of this as like t to the negative 1. That's negative t to the negative 2. Okay, I feel like we have almost everything. You just have to clean it up a little bit. So now coming over here, grabbing this information. I'll do this in the room. d2y dx2. That's equal to the derivative with respect to t of dy dx, which is this right here. So that's negative t squared over dx dt. Dx dt is just 2t. That was easy. Now let's clean it up a little bit. We have a negative. The numerator, actually, that should be negative up here too. The numerator ends up being 1 because you could grab that numerator, bring it down as a denominator, and we're left with 2t cubed. And that's it. d2y dx2. There you go. Simple as that. And now if you have any questions, please feel free to ask. Otherwise, bye.